David Thomas, please go ahead.
Okay, on my own side, can you
Okay.
hear me, sir?
Clearly, loud
All
and
right.
clear.
One of the benefits I took home on our last class is based on the access that facility manager want to take over, accept fully responsibility of taking over the facility. You need to assess and check the condition of the facility before you accept to take over, fully take over. Thank you, sir.
You're much welcome, sir. Yeah, Mr.
Can I add
Innocent.
one more thing?
Okay, Madam Rita, go ahead. Mr. Innocent, I'll come back to you. Madam Rita, go ahead, ma.
Good facility have a good asset register. You should
Exactly.
have you should have
Exactly.
the
Because your comprehensive condition assessment helps to like map out your asset register. Exactly. You're right, man. Thank you. Yeah, Mr. Innocent. Then Mr. Daniel, I'll come back to you. Let me quickly hear Mr. Innocent out. Mr. Innocent, please go ahead.
Good evening.
Good evening, Mr. Innocent.
Okay, one of my take home for in my last class was on facility condition assessment was that it is not a monopoly thing. It's not what one can be able to do alone.
Okay.
It has to involve all aspects of facility, facility, those involved in facility engineering to enable us carry out our assessments appropriately and more
Okay.
detailed.
Thank you very much, Mr. Innocent. Okay, Mr. Daniel, go ahead. Then I'll come back to you, Mr. Van der Ven.
All right, good evening, sir.
Good evening, Mr. Daniel.
Thank you for last class. The whole class was very interesting. One of the things that I learned, I took home was the benefit of the facility condition index, that it helps to compare the condition of one facility to a group of facilities.
Facility, exactly.
Yeah. And one of when you were talking about the scope of a facility condition assessment, there is one question I forgot to ask when talking about the architectural drawing and the as-built drawing. The as-built drawing, is it going to be a detailed drawing or a schematic?
No, the as-built drawing is going to be a detailed drawing.
Okay,
Not
not
schematic.
this.
No, not schematic.
Okay, thank you, sir.
You're much welcome. So, Mr.
So
Van der
sorry, sir.
Ven.
In that situation, if you are going to have a detailed drawing, do
Yes,
you
ma'am.
still need all of the stamps and approvals that you got for the initial drawing? Would you need to go through all that process?
No, you don't. It doesn't need to go through any approval anymore. It's just for your architect. It's just for your architect to make amendment on those initial drawing that he has with him, and that tells you the drawing of what exactly the building holds in terms of electrical layout, plumbing layout, HVAC layout, and tiling work and all those stuff.
Okay. All right. Thank you, sir.
Yes, ma'am. Yes, ma'am. Yeah, Mr. Van der Ven, please go ahead.
Yeah, good evening. Thank you, sir.
Good evening,
One
Mr.
of
Van der
my
Ven.
key, yes, one of my key take home was concerning the facility condition index. That's is the major metrics used in measuring the quantity of physical condition of a facility. And from what I observe, if you have done all your arithmetics and all those calculations, it gives you an idea of what to do, whether to go ahead with maintenance or do a total replacement. That was what that was one of my key take home for last week class.
Thank you very much, Mr. Van the Fan. Thank you very much. So today, what we're actually going to do is plumbing system, water, and sewage treatment plant maintenance. We're actually going to focus on water and sewage treatment plant maintenance. And I must tell you that for you to run an effective facility, water is very, very key. So these are areas we're going to cover today. Different type, it is expected that at the end of this course, you should be able to understand the different type of water treatment plant in a facility. Water storage in a facility, principle of water treatment, then difference between water treatment, maintenance, contracts, and in-house contracted services. Then what role does the consultant play in water treatment contract services? Step involved. What are the steps involved in water quality determination and water treatment process, water treatment analysis, and associated problem with water treatment maintenance, plan, and components? So we have 6 modules to quickly cover under this course. We have facility water treatment system, obtaining water treatment services, water treatment plant installation, operation and maintenance of water treatment plant concept, and water treatment plant maintenance checklist. So these are areas where we're actually going to be covering today. And I'll try to see how we can quickly close some gaps so that at least we can run up as exactly 7 o'clock as usual. And these are the times that along the line I'll be using. WTP means water treatment plant. TW means treated water. And RW means raw water. That is the water that is actually either coming from your well, your borehole, your rainwater, the water you take from the brook, or the one you take from the sea. It's still a raw water because it has not been processed. That's why it's referred to as, most of the time, some people refer to it, you might see it as fed water or raw water. Then TDS means total dissolved solid. That is the number or quantity of chemicals that has already dissolved in your water. And pH is potential of hydrogen. RO means reverse osmosis. STP means sewage treatment plant. And BOD means biological oxygen demand. And COD means carbon oxygen demand. So as time goes on, we'll be able to understand each of those abbreviations into detail. So facility water treatment system. Let me say, water is to our body what blood is to our body. And somebody tells me that water is synonymous to blood, which is nothing but the truth. Water is synonymous to blood. The way water is to our body, that is exactly the way blood is to our body. So me and you, we could have several numbers of plans that this is what I want to achieve in the nearest future. This is what I want to be. This is who I want to become. But let's not forget that the water we consume has a vital role to play for us to achieve all these things. That's the reason why it is very, very key for us to be very, very conversant with the kind of water we use and the purpose to which we use the waters for. Okay. Water is to our body what blood is to our body. Our daily survival solely depends on its numerous usage. And a successful facility operation solely depends on the availability of water. You cannot run a complex. You need water. The purpose or use of water will determine the type of water system that you are going to put in place in that facility. And in every facility, I try to always advise facility manager, the best process when it's come to water in your facility is the very first thing you do is conduct what you refer to as geophysical survey of the site. Please, I will appreciate we have all speaker muted. I said the very first thing is that if you have a site where you want to execute a project, you need to dig a borehole. The very first very first approach is for you to conduct a geophysical survey of that site. And this gives you a guideline of the depth at which you are going to get a good volume of water, even if the quality is not as what you want. And with this, it actually saves you and the driller to quote for the right material and the right cost. Because the cost of digging a 20-meter borehole will be different from the cost of digging a 60-meter borehole. So with geophysics survey, you'll be able to know the depth to which you are going to dig. And that is exactly what the digger will use to quote for you. Then the next thing is, once the borehole is being done, the very next thing is for you to take a sample of that water to the laboratory to analyze that water for you. After the analysis, that tells you what are the physical condition of the water, what are the chemical condition of the water, and what are the biological condition of that water. And with this, you will be able to determine the kind of treatment you are going to give to the water. And let's not forget, one single principle of water treatment cannot attend to all water related issues. So you define the treatment you are going to give to a water based on the associated problem with that water. And that's why you see the water treatment system include filtration system, water purification or water distillation, you have chlorination and flocculation, you have reverse osmosis, you have ion exchange. And let's not forget, there is the comment here that let your water laboratory analysis guide you in determining the best water system to put in place in order to resolve the associated problem with your water. So that Mr. Innocent is using purification method does not mean Mr. Emmanuel, will need purification method to treat my water at the same time. No. Water has different issues, and you cannot use one single treatment method to resolve all the issues that are associated with your water. And when you do your laboratory analysis, there are three factors, there are three parameters that are very, very key. Because I remember then when we were growing up, when we were doing integrated science, we were being told that water must be colorless, odorless, and tasteless. No, that is just a single parameter out of the three parameters of water. The three parameters of water include physical parameter, the second one is the chemical parameter, while the third one is the biological parameter. The physical parameter is what integrated science told us that water must be colorless, odorless, and tasteless. Then the chemical aspect of water is when we are talking about sulfur decomposition in water, you are talking about nitrate, nitrites, chlorine, you're talking about residual chlorine, you're talking about iron, you're talking about manganese, you're talking about hardness of the water, and so on. These are chemical composition of the water. Then when you are talking about the biological decomposition, you are talking about staphylococcus, you are talking about E. coli, you are talking about anaerobic mesophilic. These are all biological related with water. So my own water could be having a biological impact, while Mr. Innocent, water at its own end may be having a chemical issue. So the mode of treatment differ from each other. Then that's the one aspect of water and facility management. Then the second one is that what is the purpose of usage of that water? The water that is needed in a medical laboratory is quite different from what is needed in a facility. And it's quite different from what is required in an hotel environment. This is quite different from what is required in a car wash. This is quite different from what is required in a laundry service. That is a facility that is into soft services. So the purpose of the water also determines the kind of treatment you are going to put in place for your water treatment plan. Now, purification. Purification is the process of removing undesirable chemicals, biological and physical, like suspended solid and gaseous contaminants from water. The purpose of this is to produce water for human use, which include drinking, medical, pharmacological, chemical, and industrial usage. Purification method is the method they use to produce the sterilized water that we use in the medical laboratory or in pharmacological company where they produce our body creams, our facial cream, our body sprays, and all those stuff. Because these water are being purified. And when purification method is you subject the water to heat, the steam is accumulated in a steam accumulator. This steam is allowed to cool down. When the steam cool down, it becomes condensate. And this condensate becomes water. And that is why they call it a distilled water. It reduces the concentration of particle matter such as suspended particle, bacteria, algae, viruses, fungi, as well as the soft solid. Purification method is physical, chemical, and biological. Filtration, sedimentation, distillation, flocculation, chlorination, and ultraviolet, slow sand filter, biological active carbon. For biological aspects, most of the time, after the water has been purified and it has been distilled, and after distillation, you accumulate the steam becomes condensate, the condensate becomes water. The water is now then processed through further purification, which include filtration to remove all the unwanted material, the adding of chemical like chlorine, fluorine, or possibly passing it through a layer of ozone like ultraviolet light, or maybe possibly after that you pass it through a sand media filter that has a biological activated carbon in order to remove further odor from the water. This is another process of treating your water. Then we have the system of storage of water. You can store your water with overhead tank. You can store it with your tank on the surface ground, and you can as well store it with underground tank. Each and every of these storage has their purpose and their advantage. And why do you store your water? One, you store your water to equalize supply and demand system. You have a storage. So once you are using that storage, you have already automated your processes so that once you take some certain volume of that water out, the process commences again and it rewards, it recharge your storage tank. Then two, to increase operating convenience. So you need not to start going up and down. Going up to go and start the pump, and when the tank is filled up, you switch it off again. These are part of the conveniences you get when you automate your water treatment plant and you have a good storage. Then balance pump requirement. So your pump doesn't need to work 24 hours. Your pump only needed to comes on when there is need for you to operate. It comes on, it fill up your tank. When the tank is filled up, it's shut down. Then it also decreases power cost because as long as your pump is not working 24 hours, you are not actually consuming power 24 hours. So you use your pump for like 10-20 minutes to fill the tank back. After filling the tank back, it's shut down. And that's why you see in some facility, you have what we call a pressure switch on your pumping machine. The function of the pressure switch is to switch on, to put on the pumps when you open any tap within the facility. And once you close the tap, it builds pressure. The pressure is actually what shut down the pumping machine. So the pump is actually working on the principle of pressure. Once the pressure reduces, the pump comes on. And once the pressure increases, the pump shuts down. So emergency fire requirement. And one of the reasons why you have a large reservoir is you see that in most facilities, your fire hydrants are mostly connected to your underground tank because your underground tank can take a large volume of water. So that in case of fire emergency, you have something to fall back on. Then surge relief. In case there is high demand for water, you have a backup that you can easily fall on. These are part of the reason why you have storage. It also helps to increase aeration and chlorination and contact time. Most especially when your water is having issue related to aerobic respiration, which is absence of oxygen. When your water is having an absence of oxygen, your water will definitely smell. The aquifer of your bowl, where the water is coming from, if that water is having sulfuric decomposition, the water will smell. And in order for you to take a greater part of odor out of your water, the first thing you can do is for you to suspend the water for aeration. And when you have a large story, just like what you have in this picture, this is a large story. What this is actually doing is that the water is allowed to stay in that tank for a certain period of time so that the chemical reaction can take place, then aeration can take its effect as well. All the odor that is associated with the water, at least almost about 60 to 70% of odor associated with your water can be taken away through aeration. Then chemical contact time can actually take its own time. That's the reason why most of the time you need to have a larger storage system. Then blending water from different sources. For instance, if the cost of digging an industrial borehole is on the high side, you could do like 3 or 4 what you call a you call it shallow, you call it, most of the time you refer to it as a shallow borehole. You can do 3 or 4 shallow borehole, combine all of them together to be inside one storage system. Then from there you can now start your processing, so that you know that when the force borehole are giving you water at the same time, is almost equivalent to what a single industrial borehole will give you at the same time. So most of the time you use this one to reduce cost in project. And type of storage system that we have, you can have overhead, you can have what we call electromechanical, which is the surface type, and you can have underground. Now, when you have your tank as overhead, most especially domestic water storage system are mostly overhead tank. Hardly will you see a building, a residential building that has underground or surface storage tank. No, majority of them are overhead. And one of the advantage of the overhead tank is that water supply water to the distribution network via gravity. You are only supplying water to the entire building through what we refer to as gravity. But the only challenge with the overhead tank is that there is always what we call a pressure differential. And that's why you notice that if Mr. Innocent is living on the ground floor and Mr. Gentle is living on the first floor in a one-story building, you discover that when water is going to be out, Mr. Gentle will be the first set of people to what? To run out of water. Then followed by Mr. Innocent. And when you start pumping water, until when Mr. Innocent receive enough water, the water in Mr. Gentle floor will not be what? Flowing. And these are the challenges you have with supply water into your facility via gravity. But the only advantage of overhead storage is that you don't need to have constant supply of power for you to have water. And that's why you see in a residential area, most of the time we only use our generator to pump water to the tank. Once we pump the water, we switch our generator off, and either there is power or there is no power, we still keep having what? Water. But once the water is run out, we need to put on our power again to get water into the overhead tank. That is the difference between an overhead tank. That's one of the advantage and disadvantage of overhead tank. Then the second one is electromechanical. That is having your storage tanks on the surface of the floor. The only advantage of this is that you have equal distribution of pressure throughout the whole plumbing network. Throughout the whole plumbing network, there is equal distribution of pressure. So even if we started pumping water, Mr. Innocent and Mr. Gentle will be getting the same pressure of water at the same time. But the only disadvantage of electromechanical is that when there is no power, there is no water supply. Once the power is out, water supply is also out. Then underground, The underground system is also similar to electromechanical. That means no power, no water. But with power, there is always equal distribution of pressure throughout. And that's why you see, because the volume of water you can store when you have an underground storage system is far, far more voluminous compared to electromechanical and overhead. And that's why you see most of the time in our facility, our water, our fire suppression system are mostly connected to the underground water storage system. So what is a borehole? According to Wikipedia, a borehole is a narrow shaft hole bored into the ground either vertically or horizontally. Vertically for extraction of water and other liquid, e.g. water or petroleum. So what is the difference between, why do we call one borehole? Why do we call the other one well? Because the two of them provided water. And if you look at the two of them, they are both cylindrical in nature. Now, your borehole is drilled with specialized engineering machinery, while your well is mostly manually done. Your borehole ranges between the diameter of 4 inches to 12 inches, while your well can be more than 12 inches in diameter. The depth of your borehole could be far deeper than your well, but your well is mostly shallow because they are not as deep as borehole. You have access to large volume of water when you do a borehole, which is compared to what? Your well. Your well is seasonal. It is mostly affected by season because your well is being charged with rainwater. The only water that charge your well is rainwater. And that's why you see during the dry season, a lot of well runs out of water. Then with borehole, Mr. Lewis, please mute your speaker. Thank you. Then with borehole, you have access to cleaner and water that are less prone to surface water intrusion. But with your well, because what is actually charging your well is rainwater. So if you are having a gutter closer to the front of your house where you have your well, there is possibility of that gutter water to be recharging your well. And that's why you see at times your well could be giving you some foul smell. And at times the odor disappear. You'll be wondering why. Because if the water that is recharging your well is actually from the external drainage, there is tendency you may be having odor in your water. The first step to be taken before borehole construction is carried out the first step to be taken before borehole drilling is to be carried out at a site is for you to do what we call a geophysical survey. The geophysical survey, like I explained, helps you to determine the required drill depth, material cost, and best yield of aquifer. That is the aquifer that is going to give you the best volume of water. And we have the definition of each of those we have the aquifer is a geological formation that will yield water in sufficient quantity. The bore diameter is the diameter of the hole made by the drilling bit, 5 inches, 6 inches, 8 inches, or 12 inches. Most industrial borehole are drilled at 12 inches and you do the casing at 8 inches. Casing can be a UPVC, it can be a PVC, a mild steel, or a stainless steel. Then your screen is a pipe with perforation or slot that allow water into the column. Then you have wellhead or cover. That is that iron that they use to cover your borehole. Then the marine rope is the rope that they use to suspend your submersible inside your water. Then why do we need to treat water? Water treatment means the chemical or mechanical removal of ionic, non-ionic substance in raw water. I've explained to us what raw water means the other time. That is an untreated water, substance in raw water to produce water for a predefined use. Let's not forget that word, predefined use. Is it going to be used for medical purpose? Is the water going to be used for pharmacological purpose? Is the water going to be used for pharmaceutical purpose? Will the water be used for beverages like all these Coca-Cola, Brewery, Chivitas, and all those stuff? Will the water be used for laundry? Are you actually using the water for domestic purposes like cleaning of floor, flushing of toilet, flushing of urinary and all this stuff? So you need to have a predetermined purpose of what you're actually going to use the water for. So that will help you to determine the kind of treatment you are going to give to the water. And at the same time, this helps you to determine the cost. Then, what is the benefit of treating your water? One, to make the matter palatable and pleasant to drink, at least the matter that the water contains. Then, for the removal of color and odor. Then, 3, to make the water free of pathogenic organisms. Then, 4, to make it free of corrosive elements like your iron, like your lead, like your nitrate, nitrite, that can affect human as well as equipment through scoring, scaling, and corroding. Like if you work in an hotel environment where you have a central water boiling system, that you have a boiler. If your water is having what we call hardness, there is tendency of you having scaling on the element of your boiler. And because of this might be causing you to be replacing the element of your boiler often and often. Same thing applies to your water heater. Your water heater can be forming scaling as a result of iron or hardness in your water. And this will be causing you to lose the element of your water heater most of the time. And that's why it's very, very key for you to ensure that you work on your water physical, biological, and chemical composition of your water. So for every water system, the process might be improved, but every water system goes through this process. The process may now differ from one usage to the other, but every water treatment system go through this process. Raw water, it all depends on where your water is coming from. This raw water could be rainwater. This raw water could be water from the brook. It could be water from the sea. It could be water from your well, and it could as well be water from your borehole. So your raw water can be any water. It's like the source of the water. So if you are going to use a well water, you need to take a sample of that well and analyze it first. Then, if you are using a water, you need to take a sample of that seawater and analyze it well. Then the second thing is the water comes from your source, which is the raw water, to a storage tank, mostly referred to as pre-chemical treatment tank. Now, if your water has odor, it has to go through aeration. But if your water does not have odor, aeration can be removed. Then it goes through either coagulation or flocculation. From there, it goes through sedimentation to remove all the sediment, because when you use chlorine for flocculation and you use your alum for coagulation, this causes the water, the dirt inside the water, to form what we refer to as floc. This floc become heavy and heavier than the weight of water. So they fall to the base of the container that contain them. And this is referred to as sediment. Then the next thing is that you do what is referred to as disinfection by adding what? Chlorine, or you allow it to pass through a UV light. Then the next thing is softening. Softening or filtration. Softening can be done via filtration. Your filtration cylinder can be stainless steel or fiber. Then the water that comes from the filtration process is referred to as treated water. Water that has gone through biological, physical, and chemical processes is called a treated water. Then If you need this water further treated, maybe after you have taken the treated water to the laboratory, the water is found to be containing nitrate, nitrite. Then the next thing you can do is to pass the water through what we call reverse osmosis. Your reverse osmosis can help you to remove nitrate, nitrite, and improve the pH of your water. So we spoke about the pre-chemical treatment, we spoke about the aeration, and in terms of aeration, there are two types of aeration system that you have. One is what we refer to as water into air, and the second one is what we refer to as air into water. The water into air is the one that most of the facilities, you get to some facilities, you see that the water that is coming into the aeration tank is coming in form of a shower in your bedroom. That is water to air. You are suspending the water to shower. In the process of that, because oxygen is readily available in nature, the oxygen is being provided, subjected into that water. Then that takes care of odor. Or you install what we call a blower. The blower is what is pushing air into the water. That's why we call it air into water. When the blower started working, you see bubbles coming inside your aeration tank. That bubbles is the injection of oxygen into the water. So your aeration can be water to air, or it can be air to water. Coagulation, like I said, is a water treatment process of making condition favorable for colloid to join together to form flux by biological or chemical means. Biological means that after fetching the water, you leave the water naturally, you allow the water to settle by itself to the base of the container instead of adding alum to it. Adding alum or polymer to raw water, tiny fine particles of dirt in the water stick together and they settle at the base of the container. These are the process of flocculation. That is, you add alum to your water and you allow the sediment to stay at the base. And that's why you see the raw water is coming in, your lime or your floccular alum is being added to it. So all the sediment will stay at its base. Then this is now allowed to pass through filtration with, this is your aeration tank that inject carbon dioxide to take care of odor. Then you do chlorination for what? For disinfection. Then here you have your water. Then the finished treated water goes out from this container. This is a process of treatment as well. Then I've already explained what flocculation means. And sedimentation. Sedimentation remove sediment from water. The heavy dense particles settle to the bottom of the basin. The settled particle form sludge on the bottom of the basins, and the accumulated sludge is periodically removed from the basin or during routine maintenance. So if you have this type of aeration in your system on quarterly basis or monthly basis, you can easily open this valve here. When you open the valve, all the sediment that has already accumulated here are being discharged completely out. Then you have the opportunity to wash the interior surface of this. Then filtration is, let me just give an example of that filtration. Many of us that are science students know what we call by filtration process in science. That you have a filter paper, you pour, when you mix chalk and water together, the water only become milky because chalk is not completely soluble chemical in water. So you can use filtration process to separate your chalk and your water. That is exactly what filtration process is doing. And accumulated contaminant inside the filtration filter. The filtration filter can be fiber, it can be stainless steel, it can be mild steel. Then the process of removing the accumulated sediment from the filtration system is the process that we refer to as backwashing. So disinfection, you can use your chlorine as a disinfectant. A very effective disinfectant is chlorine. Chlorine is added after the clarified water leaves the settling basin. Chlorine helps to guard against possible contamination in the water distribution system. It is a common chemical method to kill any pathogens or to deactivate any potential harmful microorganism in storage and distribution system. Excuse me. Other disinfectants are chlorine, ammonia, chlorine dioxide, ozone disinfection, or ultraviolet disinfection. If you expose your water to the sunlight, is as a means of disinfection at the same time. I told us that reverse osmosis can help us to improve the pH of our water and at the same time also help us to remove nitrate and nitrites from our water. So reverse osmosis is a movement of from higher concentration to a lower concentration through a semi-permeable membrane. So that's why you see people that are into reverse osmosis design and installation speaking mostly about what we call membrane. The majority of us will be wondering what is a membrane. That is what is actually doing the filtration. It is an higher filtration process of producing water. Then distillation. We've already explained this before. You subject the water to heat. After heating the water, the steam is accumulated. After accumulating the steam is allowed to condense. After condensation takes place, the condensation is now allowed to form water. The softening. When your water have hardness, just like I explained earlier on, if you are in a facility that is into hospitality, you could be having your boiler having scaling, or if you are in a facility that is into laundry services, then you could be wasting a lot of soap because hardness will not allow your soap to go through process of what we call saponification. So instead for you to use 2 liters of water for maybe 20 kg of cloth, you might be using like 4 liters of what? Soap because of hardness. So when your water is having hardness, the best you can do is to use what we call softening process. And the softening process is by adding calcium or magnesium triazocarbonate to that water or substitute it with aqueous exchange by the use of resin. Then, obtaining water treatment services. Your water treatment can be maintained in-house by your technicians, and you can contract your water treatment maintenance out to a third service provider. It all depends. But one thing you need to have at the back of your mind is that you need to do what we call cost comparison. You compare the cost of doing it in-house to the cost of doing it externally. Whichever one is cost effective, that is exactly the one you're going to do. Water treatment services process commences with what type of services do you want? Then you need to conduct a research or do a networking among facility colleagues to know who provide the excellent service in this area. Give access to at least 3 different service providers for a detailed assessment. Let 3 water treatment service providers come and assess your water treatment. Let the 3 of them provide their report and their cost. Compare. Then you can now choose which one is the best. Collect the report and quote after the assessment. Invite the service provider for a thorough interview. Do not justify a contract award based on low bidder only. Then after you have decided to give out the contract to a certain contractor out of those 3, the next thing you need to do is you need to design your KPI. You need to design your scope of work, then design what are your expectations, what are the deliverables you want from the contractor. And you need to include this in your service level agreement. And after that, what is the difference between doing the contract in-house or contracting the service to an external contractor? Let's look at it holistically. Either contracted or in-house service. Always remember your top priority is to improve performance at a good and acceptable price. Contracted services are advantageous in that 1, it helps you to reduce the service level. Cost savings in terms of operational training required for staff. So you don't need to start sending your staff to be experts in water treatment. So your staff can concentrate on other core facility maintenance or management requirements. Then it also gives you access to experts who are more experienced and knowledgeable as far as water treatment plant is concerned. For instance, you happen to be a facility manager in Lagos State Water Corporation, or you have a facility, but as at that time, when the facility come on, you don't have the financial capacity to set up a water treatment. You can call up water treatment expert companies, call them, tell them, set a water treatment plant in my facility, start selling water to the occupant, and start charging them so amount. So every 100,000 naira you make on supply, you are going to pay me a facility availability that I created for you. You are going to pay me 20% of whatever cost you are making every month. This is another angle as well. With this, you are less concerned about either water is available in the facility or not, because you have already make it as part of your scope of work that there must be availability of water. So when water is not available for a certain period of time, you can sanction the company. Then it brings insight into compliance management, allow organization to navigate regulatory requirements effectively. So when Lagos State regulatory when Lagos State regulatory ministries commissions are coming around, when health commissions are coming around, when other regulatories are coming around, or NAFDAC are coming around, you are less bothered about what's treatment plant. It is the responsibility of the contractor or of the service provider to make sure he provided all the necessary documents that will be asked during that inspection to the what? To the commission. Then leveraging on the expert of the outsourced company, the organization can reduce downtime, optimize asset utilization, and higher asset availability, which will thereby improve service and customer satisfaction, because you have a company that's giving you 24-hour water supply day in, day out. This is an example of what is actually happening in Banana Island. Banana Island has a contractor that constructed a water treatment plant in that estate. So every occupant of that estate has their piping network metered. So the payment goes to Banana Estate. So at every month, both Banana Estate, Banana Island Estate, and the water treatment expert, they do what we call account reconciliation. This is the total amount we make from water. This is your own quota of it. This is our own quota of it. But you can agree with me that day in, day out, 24 hours on a daily basis, there is always water supply on that estate. And the estate can boast of this, can be part of your sales opportunity. This can be part of what you are going to be telling people who are willing to come into your facility, that okay, we can guarantee you 24-hour power supply. Then what is the disadvantage of contracting your water treatment house to outside sources? It could be expensive considering how bogus your system is. If you are not having a system as bogus as Banana Island, a system as bogus as 1004, you may not need to go to that extent. You can get your water treatment maintained and controlled in-house. Less control over the process and decision. Because you are not the one in control, you have less control over how the process are being done. Maybe you're supposed to use 20 kg of chlorine. How do you determine they're actually using 20 kg of chlorine? Then cost maximizing. Contractor may maximize cost by reducing quality in a way that it is difficult for an organization to verify. This is another way. How are you sure that the quality of the chemical they are using is the right quality. Acceptance of low bid may lead to inferior quality of work. So maybe at the end of the day, you have given the job to a contractor who gave you a lesser cost. With this, you might be getting an inferior quality of work at the same time. So when you do your when you maintain your water treatment in-house, what do you start to gain? The organization maximizes full control over the entire operation and decision making on the plant. So you are the alpha and the omega of your treatment plant. Nobody controls it for you. You can decide, oh, this night I want to do maintenance. This night we must do chlorination. This night we must do flocculation. This tomorrow, this is the quality of water we want. And the organization has the capability to customize its treatment plant method to a specific need. You can customize your treatment plant to your need. So a contractor may tell you that you need 1 million liters per day, but you are the one that actually know what you need. You can design your need based on your specific need. The company can avoid paying continuous service fee to a contractor, which can add up significantly over time. So you know that either you use water in the facility or you don't use water. At the end of every month, you need to pay your maintenance or service agreement. So, and even when occupants are not using enough water, you still have to pay. If they are using excess water, if you have to pay. So a sustainable opportunity exists in that the wastewater generated can be reused, thereby reducing demand for fresh water and supporting environmental goal. This is an area when you have a larger facility. Let's take an example for 1004 estates. Imagine the kind of water treatment 1004 estates we have. It's going to be very bogus, very huge. You can imagine when 1004 is doing backwashing and they are discharging the water to the public draining. What do you think is going to happen to the whole of that environment? The whole of that environment is going to be what? Flooded. Because the volume of water that will be coming out from their backwashing will be huge. But because in order to reduce how much their submersible will be working and also to support environmental goal, they recycle their backwashing. The backwashing is recycled back into the aeration tank to now go through another process. So when they want to do backwashing, it can be once in a quarter, it can be once in 6 months. So that is also a means of saving sorry, there is a network itch there. So what are the disadvantages when you do your water treatment in-house? It is capitally intensive that in terms of capital expenditure and operating expenditure, this can be prohibited for company with limited capital resources. Imagine you don't have the financial capacity and you want to execute the size of what we have in 1004. Then skilled personnel are needed to operate and maintain treatment plant, and this require ongoing investment in training and salary. Operational skill, technical failure, human error, unforeseen problem can interrupt the treatment process, thereby posing a risk to both the environment and the business operation. That's why you see in some facility, most of the time you see that the water is either tasting bitter or the water is somehow maybe brownish in color. If the process are not being followed by the maintenance team, it's going to actually impact on the quality of the water when produced. So water treatment full and support service. There are two types of agreements you can sign when you are signing an agreement with an external vendor to maintain your water treatment. You can do what we call a support service agreement, and you can do what we call a comprehensive agreement. Water treatment service contract can be full or a support service. Full service, which is mostly referred to as comprehensive service. Comprehensive service spells out service to be provided in terms of maintenance, system repair, chemical provision, manpower, and reporting mode. Each detail in the service has an assigned fixed cost. So if you are signing a comprehensive maintenance for a 1 year, within that 1 year, any repair that come across will be borne by the contractor because he must have charged the cost of everything inclusive into his contract. So even if a pump fails, it's not your problem. It is the responsibility of the contractor to make a replacement of that pump at no cost to you. That is a comprehensive agreement. But when it is each detail in the service has an agreed fixed cost, which cannot be reduced or increased during the contract duration by each party involved. Advantage is that it is less affected by market price and price variation. All prices are involved and are well negotiated and agreed on by both parties. Part replacement during repair has an agreed price. It has been agreed. You can't pay any other thing. Then the support service more or less like what we refer to as pay as go. You pay the guy for normal routine service. You have an agreed price for normal routine service. Then when repair comes around, the only thing is that you don't allow any other vendor to do the repair. That is the only sole vendor that will be carrying out repair. And once it does repair, the only advantage you enjoy is most of the time if you negotiated better, the only advantage you get is the vendor cannot charge you for labor. If you negotiated well, then it cannot charge you for what we call out services. So that means you have the opportunity to call as many times as you have any breakdown. So it's the responsibility of the contractor to come around to get the issue fixed. If a part is replaced, that is when the guy will now charge you money. The only fixed cost here is the cost of routine services. Maintenance is pay as you go. Market value may bring maintenance cost or down. A low quality part may creep in. May contribute to non-continuous system breakdown. May contribute to continuous system breakdown. The plant may receive less attention, which can impact on service delivery during the period when a contractor pull out and before re-awarding the contract again. So if as a result of one contractor is not giving the right service, it's not deliver the right service, you remove the contractor before the process of getting another contractor to come and man your water treatment plant again. It might take a span of maybe 1 or 2 months. Who take control within that period? And during that period in time, it can affect service delivery. It can affect a lot of things. You can have a lot of downtime, which is going to impact on service delivery. These are areas where you lose some money in terms of service delivery. So it's already 6 o'clock. Let's quickly observe a 10-minute break. And by 6:10, we'll come back to come and continue from role of consultant in contracted water treatment contracted service. Thank you. 10-minute break start from now. This is 18602. So by 6:12, we converge again. Thank you very much.
Thank you, sir.
Hello, is the meeting still on?
We're on break.
Okay, thank you.
Hello? Hello?
Welcome back, sir.
Okay, thank you very much. So What is the role of consultants in contracted water treatment contract service? Why do you need to take the service of a consultant? One of the things you need to do, one of the reasons why is that the consultant provide knowledge and expertise by the consultant help you to evaluate the operating parameters and existing condition of each treated plant to determine the best approach to your water treatment. That is one. For instance, you are trying to set up a huge water treatment plant, and you as a facility manager, you don't have a detailed knowledge as far as water treatment is concerned, and you want the best. You can take the support of a contractor, of a consultant to help you review the quotation, see who actually knows, interview the water treatment service provider and see who actually will give you the best of the best. Develop it will also help you, consultant will help you to develop a comprehensive specification that include measurable performance objective. Then support facility personnel responsible for in-house monitoring to ensure that the right things are being done. A consultant can help you monitor how your in-house team are maintaining the facility management. You can drop up a checklist, develop a checklist, and once in a while come around to check if those guys are actually doing the right thing so that you can be getting the right water at the right time. Then review contractor performance regularly to ensure the contractor address any deficiency properly. Also ensure all effective relationship between you so water treatment operation. Water treatment operators training. What are the kind of training you give to your team? Technical expertise, and the advantage that your team gets when you train them as far as your water treatment. Technical expertise, operator training exposes equipment personnel to technical expertise necessary for the successful operation of the plant, thereby guaranteeing availability and uptime, then implementation of best practices. It helps you to improve your productivity. Well-trained operators can perform their tasks more effectively, leading to increased production output and reduced downtime. Then also reduce error. Operator training helps operators understand their responsibility and tasks better, resulting in few error and rework. And operator efficiency with when you provide training to your in-house team, trained operator can optimize treatment process, leading to better water quality. These are what you stand to gain when you give a quality training to your team as far as water treatment is concerned. Water treatment installation. Water treatment quality refers to the chemical, biological, radiological characteristics of the water, which I've already mentioned earlier on. Then how do you determine water quality? Knowing the water quality is a major key in installing a water treatment plant. It determines the applicable application for treatment, and water with high quality will require minimal treatment. When you have high quality of water, When you have high quality, water with high quality will require minimal treatment. And selection of water treatment system. Like I explained earlier on, what are the kind of treatment you want to put in place? Is your water having hardness? That will determine the kind of treatment. What is the quality that you want? Is it a water that is meant for domestic usage? Is it a water that is meant for drinking? So when you need a water for domestic purpose, why are you spending money, a huge amount of money treating the water for domestic consumption, which is drinking, which and at the end of the day, you won't eventually drink the water. And you still have to start spending money to buy water externally. So you need to determine then what is the capacity that you want. You are living in a 3-bedroom flat and you want to spend millions of naira, like 20, 30 million naira to get water. What for? Provision of good quality of water. The treated water reduces the harsh effect on the skin, and the treated water does not damage laundry. Those are the major things you needed your water for. For drinking, that you need to go for the comprehensive aspect of treatment. And we said physical, which indicates detectable, like color, odor, taste. Chemical is the sort of chemicals like chlorine, sulfur, and all those stuff. Biological is the presence of microorganisms and bacteria like your staphylococcus, your E. coli, your anaerobic mesophilics, and all those stuff. These are all biological impactation on water. And this is example of a water quality, pH. For water, for drinking water, your pH should be between 6.5 and 8.5 according to NAFDAC and WHO, that is World Health Organization. Your turbidity, that is the color of the water, should be less than 5 TU. And the chlorine, residual chlorine composition in your water should be between 0.2 to 1 to 0.2 ppm. That is part per million. Part per million is the measurement of the dissolved solid in your water. Then the total dissolved solid in terms of chemical, which is chlorine, magnesium, calcium, total dissolved solid, lead, nitrate, nitrites, iron, it should not be more than 500 milligrams per liter of dissolved solid. And copper should be 1.3 milligram per liter. Manganese should be 1.05 milligram per liter. And if you go beyond this, it will give you a bitter taste, black stain on laundry and fixtures. Then chlorine, you have, it must not be more than 250 milligram per liter. And when it is in excess of that, it starts blackening. Your stainless steel starts becoming blackish and brackish or still tasty. Then sulfate, it must not be more than 250 milligram per liter. And if it is more than that, start having laxative effect or greasy feel on your water, on your equipment service. Then iron, your iron must not be more than 0.3 milligram per liter. If it is more than that, you start having yellowish stain, discolored beverages, stained laundry, and metallic taste as well. And pH, like I said, the acceptable pH is 6.5 to 8.5. So when your pH is higher, if you're having like above 8.5, that means you need an adjustment. You can use filtration, you can use lime to achieve the desired pH level. Lime helps to stabilize the natural soft water. Lime reduces corrosion in distribution system. Then adjust the pH to make water more basic and less corrosive to pipe. Extend the life of disinfectant residue as well. Then operation and maintenance of water treatment. What are the kind of maintenance activity do you carry out in your water treatment? You do daily maintenance, you do weekly maintenance, you do monthly maintenance, quarterly maintenance, you do annual maintenance, and you do yearly maintenance. Daily, dosing of the chemical, backwashing of the filtration vessels, check for functionality of your pump, dosing pump and stirrer, transfer pump, then check pH, chlorine and TDS level. Then on a monthly basis, you wash your dosing tanks, you remove, most especially if you are using grain chlorine. Grain chlorine is always insoluble in water, so it settles at the base of the container, of the dosing container. So once in a while, you remove the sediment, you wash the tank, then servicing of the chemical dosing equipment, servicing of the filtration, transfer pump, and laboratory analysis. So it is expedient that you take your water sample to laboratory to analyze it every 6 months. It is very, very necessary. Then you make a replacement of the media inside your filtration cylinders on an annual basis. It must be done on an annual basis. On the mainland, you can do between 12 to 18 months on the mainland, but on the island, or if your water contains more of iron, you can ensure you do between 9 to 12 months replacement of filtration media. Washing of aeration tank, quarterly you wash aeration tanks and water storage tank, replacement of filter media. Then annually, carry out overhaul of your pump, carry out overhaul of your filter vessel, tighten bolt and nut and replace weak one. Annual maintenance, your servicing of your borehole, most especially if your borehole is sink in an area where there is a huge composition of iron, or there is huge composition of clay or mud. Definitely you need to do what we call flushing. If you're having borehole around the Apapa area, around Amuwo Dolphin axis, around the Okota side, then you need this. But if you're having a borehole around the Keja area, down to GRA, down to Yanopaja axis, down to all those Songo area, you could be doing your borehole flushing within a span of 18 months. But if your borehole is within Ojota area, down to all this Opic side, you have to do an annual flushing of the borehole, because those areas either they are with a lot of sulfuric decomposition, iron, or clay. Some of these tasks are automated in modern water treatment plants, but trained personnel are still required to control and maintain the system. Some of these tasks are automated in modern water treatment plants, but trained personnel are still required to control and sustain the system. What are the hazards associated with water treatment plant? Exposure to hazard substances like I always try to advise people, if you are asthmatics, stay away from chlorine because it's of its what choking smell. Tips, trip and fall, exposure to high level of noise, exposure to toxic substances, electric shock, fire hazard, suffocation. Then preventive measure. Safety shoes with non-skid soles should be worn, because your soda ash, if it fell on the floor, it's most of the time slippery. Use to appropriate air protection. If you're working in a large water treatment plant, properly guard all equipment moving parts. Use MSDS means manufacturing data sheet. Then you have check air quality of the confined area, thoroughly check all electrical equipment, use respiratory and gas masks, most especially when you are dealing with chlorine. Wear coverall and wear hand glove. So what are the consents? Aeration tank, we already mentioned that you use that one to eliminate odor in your water. Filtration vessel, your filtration vessel could be metal, it could be stainless steel, and it could be fiber. Dosing pumps, your dosing pumps are used for the required rates of chemical into your water. It determines the chemical. You don't overdose and you don't underdose. Water requires chemical dosing control. The chlorine level, pH balance, and other water quality criteria. Sterile, because your lime and your chlorine are completely insoluble chemical in water. That's why you see any water treatment plant where they are using grain chlorine, there is always a sterile on the dosing tank, or when they are using lime, there is always a sterile. The reason why is that once the sterile is working, it disallows the chlorine or the lime to settle at the base of the container. So it keeps on stirring it. Then the transfer pump, that is what you use to transfer water either from the aeration tank to go through the process of filtration down to the treated water tank, then from the water treated tank to possibly overhead tank or distributed within the building. Then let me digress a bit. Most facility manager always make a mistake of using the normal service pump to pump sewage. It's wrong. Your sewage pump are not designed to pump sewage because your sewage water has debris. It has stones, it has nylon, it has sticks, it has a lot of foreign material. So when you use service pump, the impeller of service pump are either made of plastic, fiber, or stainless steel. And if the impeller is made of stainless steel, and this impeller happen to be a closed impeller, the impeller will, within a span of 1 or 2 days, to get choked up. And when it gets choked up, the pump will be working and nothing will come out of the pump. And if the pump continues to operate in this format, it will burn. So there is a sewage pump. Sewage pumps are designed for sewage. These are the pump that their impeller can stand what we call abrasive force. So even when stone comes inside, it's grind that you can use for your water treatment plant. The daily, the company name, monthly, you can design your own according to your specification. So what is the raw water TDS? What is the treated water TDS? What is your observation? What is the recommendation, the signature? Then these are more or less like a monthly treatment plant. Tax, non-water, non-treated water tank washing, treated tank washing, RO water tank washing if you have reverse osmosis, water treatment plant cleaning. Who perform the operation? Observation during the cleaning. Supervised by, you can design your own to suit your purpose. These are more or less like, this is an example of another weekly checks. This is like a weekly check. Filter, you remove the filter candle, you wash it. Activated carbon filter, you wash it. Filtration tank back washing done. RO membrane back washing done. Water treatment area cleaning done. So date is being done, who did it, and what are the comments. Week 1, week 2, week 3, week 4. So these are part of what checklist you can design for your technicians. And when you come around as the maintenance, as the facility manager, you ask for their checklist, you check if they are actually performing. There are times you can ask them to do the back washing and you see if they are actually doing it or not. Mr. Ekunle Yemuiwa. Okay, let me quickly tolerate your question for just 2 minutes. Go ahead.
So sorry. Good afternoon. Good evening. I just want to the primary responsibility and secondary responsibility. I just wanted to clarify that.
If you do this kind of a thing, the primary responsibility is the technician carrying out the task. The primary responsibility could be the supervisor who come around to check, or if it happened to be in a lettable area like an estate, if each of the block of flat has their own treatment plant, the secondary responsibility becomes the owner of that flat. He will be the one to sign that actually the technician comes around to come and do the backwashing. That is where the secondary responsibility comes in. Then sewage treatment plant. Why? One of the building code in Lagos State is that if you have a facility that is beyond two-story building, you must have a sewage treatment plant in place. And what do you use sewage treatment plant for? Let me just do a brief explanation before we start going through the slides. You treat your sewage. If you treat your sewage and your sewage give you the standard BOD. BOD means, this is what we mentioned at the abbreviation level in the initial stage of this class. BOD means biological oxygen demand. If you take a sample of your treated water, your sewage treated water, you take it to laboratory and you have the required BOD level, you stand the chance of discharging your treated sewage water into the public drain. But if your water doesn't pass, don't try it because you'll be sanctioned on it. And that's why when any of these Lagos State Health Ministry or whatever comes to your facility, the first thing they request for is, where is your sewage treatment plant analysis? And if you cannot produce that, that becomes an issue. And let me just give us a brief explanation of what the sewage look like. Now, the water you have treated, we spoke about the water that comes from either the sea, the rain, the borehole, down into our facility. This water, we either use it to wash plates, or we use it in our urinary, or we use it to take our bath, or we use it for industrial purposes. And this water, we send it to our sewage treatment plant. In your sewage treatment plant, we have, let me say, 4 chambers. It all depends on how it is being designed, but most of the time, it is always divided into 4 chambers. The very first chamber is what we call the accumulator. That is the receiver. And this receiver always have a screen. The function of the screen is to ensure it removes all unwanted foreign material that is coming alongside with what? With the wastewater, like stick, leaves, nylon, hand glove, pad, and any other. And that's why you see the screen is always like a net. It removes all this. So the only thing that passes through the screen is oil, your rice grain, your beans grain, the one you throw into your dishwashing basin, or your pepper, those small particles that you throw into your basin. That goes into an area that we refer to as an aeration tank. And inside this aeration tank, the water is allowed to settle for a certain period of time. And this is where we call anaerobic respiration take place. You allow all your food items to get decomposed through a biological composition. Your rice grains that comes along with your waste, your beans, your eba, your amala, your shawarma that you didn't finish, your cabbage, all those stuff go through biological decomposition. They decompose through biological process, because when you allow it to stay inside the second chamber of that sewage treatment plant, it grow what we call microorganism, and it grow bacteria. These microorganisms, these bacteria are responsible for the biological decomposition of that sewage, of those food related material. And that's why if you open the second chamber of your sewage, it is full of a lot of odor. And this is allowed to stay for a certain period of that. And in that point is where we perform what is called skimming. Skimming is other material that comes into the second stage of the sewage. You use what we call, skimming is like a process. You've seen all our mother that sell akara. That is these all small crumbs of akara that they use their spoon, this bigger spoon, to scoop. That is a process called skimming in sewage treatment plant. You skim to remove all those particles that float on the surface of that aeration. Then the rainwater that is mixed with oil and every other thing goes out. During the biological decomposition, all your food related items settles after decomposition at the base of that aeration tank. And these are referred to as sludge. This sludge, if you accumulate in a large content, can be used to produce what we call a biogas or a biofuel. And that's why you see some people tell you that they can use your sewage, the sludge of your sewage, to produce diesel. It's possible, but it has to be in a larger scale. and you need to take a sample of that sludge to the laboratory to analyze it to see the quantity of AGO diesel that it contains that you can yield from it. So if you have a smaller quantity, though, because the cost of producing it will be higher than the liters of diesel you can actually get from it. That's why you use it to produce what you call a biogas. That is biological decomposition gas. And your biogas, the major component of your biogas is methane, which is CH4. When you look at your hydrocarbon chain in chemistry, CH4 is methane. That is the major composition of your biogas. And that's why when you do biological decomposition of your whatever, of your waste, you can get a gas. Most of the time, in an environment, you can flare this gas or can use this gas for cooking. Then after that, it goes to you have another chambers again. We have the primary and the secondary before it gets to the tertiary. It goes to the primary. From the primary, that is where you start doing your disinfection, applying your chlorine and every other thing. Then from there, it goes to the what? To the secondary. From the secondary, it goes to the tertiary. From the tertiary is where you do your filtration and every other thing. And what comes out becomes a treated sewage water, which you can easily dispose of into the public drainage. And before you stand the chance of disposing this off to the public drainage, you need to take it to the laboratory to go and analyze it. So sewage is the liquid from our bedroom, toilet, kitchen, and waste from industry. So the receiver, you have the receiver first, which is the screen chamber, equalization tank, aeration tank, settling tank, before it gets to the clarified water sump, before you do filtration, before it goes to filtration process and it becomes a treated sewage. After treated sewage, you start what we call disinfection before. And this water, if you want to start using it for drinking, you can now allow it to go through the process of water treatment we've already discussed. So the sewage water now, treated sewage water now become your raw water that go through another process again before it can be used for domestic purpose or drinking. I know somebody will be telling me, how can I be drinking a sewage water? If you don't want to drink a sewage water, don't travel to US, because Americans use what we call recycle to do their water. So if you don't want to take a sewage water, try as much as possible not to apply for US visa. Thank you very much. So we have the sewage containment in your sewage treatment plant. We can have activated sludge process system. We can have biological contact sewage treatment. Somebody dropped a comment. Madam Rita, is the truth. America, you can Google it. They do water recycle. They don't have a good quality water like we have water every here and there in Nigeria. They do recycle. Your toilet water, you can recycle it to use it again to flush your toilet. And if you want to go further, you can do reverse osmosis to make the water suitable for cooking and every other domestic purpose. And that's why you see in Germany, beer is it's less expensive compared to water. So, and that's why they say the Germans are more or less like the beer consumers. So these are more or less like because they needed water for sewage, they needed water for irrigation, they needed water for domestic purpose. That's why they do a lot with recycling, because they don't have water as readily available as what we have in Nigeria. Then in aeration system that I've already mentioned, these are type of aeration we have. We have extended aeration sewage treatment plant. We have filter sewage treatment plant. We have reed bed sewage treatment plant. They differ based on the kind of treatment we want to have. We have submerged aerated filter, we have suspended media filter, and we have sequence batch reactor. So maintenance of your water sewage treatment plant can be quarterly, biannually, and annually. Maintenance ensure plant functionality and plant function efficiently. Maintenance prevents plant from becoming a pollution hazard, because most especially when your sewage is going through biological decomposition, the odor can be as bad as anything you can tell. Because you can even take a look at it. Take a beans, when if you cook beans today, leave it inside a bowl, cover it up, and just give it like 2 days. Leave it in your kitchen if you are able to stay in that kitchen that day. This is how smelly your sewage could be. So the process is what I've already explained. The pretreatment is the receiver where you dump all the waste into, and I told you it has a large screen. After that, this is where in the pretreatment, that's why you remove all your wanted material like sand, stone, large object, nappies, sanitary wares, face wipe, cotton board, and all those ones. Then you perform your skimmer, air blower, you inject air into it. Then the primary sewage treatment is where you do your normal biological decomposition. That is where this is being held for a certain period of time so that all the solid settles at the base of the primary container. Then the secondary container is where your biological decomposition takes place through the help of microorganisms and bacteria. From there, it goes to the second stage of the secondary treatment. This is where you do your growth of biomass, passage of sewage over the media, and removal of high level of organic material. And this is the point where you can get your sludge that you can use for your biogas. Then from there, it goes to the tertiary treatment. The tertiary treatment is more or less the final stage of your sludge, final stage of your treatment where you start doing what is called disinfection. And after the disinfection, you can now take a sample to the laboratory to analyze it. If it passed, then you can discharge it to what? To the public drain. And if you are having a smaller facility, and you deal with a lot of fat and oil, you can do what we call a fat trap. A fat trap is just like a mini sewage treatment plant, just only that the only thing that one can handle is fat alone. It cannot handle biological decomposition. Then your sludge can be used to generate electricity, or you can use to generate biogas. What are the maintenance you do? Like we said, you do monthly, quarterly, and annually. These are all equipment you can use you fund within your sewage plant. The blower, the sewage pump, and all the stuff. So this is how a sewage plant laboratory analysis should be. Before it is being treated, is 6.5 to 7.5. After treated, is 6.5 to 7.5. So your water should be 6.5 to 8.5, but your sewage should be between 6.5 to 7.5 in terms of pH. Your BOD, which I mentioned, biological oxygen demand, raw sewage must be between 200 to 250, but treated sewage must be less than 10 milligrams per liter. Mr. David, please, let your speaker be muted. Thank you. Your turbidity should be less than 10 NTU, and equally is anaerobic condition, that is absence of oxygen. Compound formed from protein degradation, that is your beans, your food item, when they degraded through biological means, emit very strange smell. Pretreatment and treatment stage form compound that contain foul odor. And what are those things that cause odor? Nitrogen, sulfur, ketones, acid, and anhydride. Odor affect the quality of life of those that are constantly exposed to sewage sludge. And that's why you have to try as much as possible to reduce it. How do you reduce odor from your sewage? You do chlorine disinfection, carbon reactor, calcium nitrate, hydrogen peroxide, and iron salt. And these are what you can use. And what are the effects of sewage on your pipe? Corrosion. It can damage your pump, tanks, and all material that the sewage comes in contact with. These are all challenges you find with your sewage. And how do you control your pipe corrosion? You make your pipe to be of inert material, like all these fiber. Fiber are less affected by corrosion. Then RCC material, all this your PPR pipe and all those stuff are all inert material. Then good ventilation around the inlet to remove condensation. Then periodic flushing of your sewage also helps to remove corrosion. Then there are some insects that are very, very familiar with sewage, and that's why you need to control your sewage very well. If you didn't control your sewage very well, people living within your estate will start complaining about a lot of cockroaches, midget. The charge of inadequate treatment sewage causes midget. Midget are potential health problem in sewage treatment plant. They causes allergic reaction and sensitization in human being, like they help in spread of diseases, many diseases and health issues. So and that's why when your sewage does not pass the right BOD, you can't be charged, because it's going to help in spreading of diseases like pollution of your water around that area, spread of diseases, and it also destroy aquatic living as well. So this might find their way. Sorry, the network has been. Hello? Can you all hear me, please?
We are with you, sir.
Yes,
Okay,
sir.
sorry,
Yes, I can hear you.
network each there. So the assessment should be submitted through the right portal as we've been doing it before. So let's go for question and answer before we call it a day today. Kindly signify by raising up your hand for questions. Okay, Mr. Daniel, go ahead, sir, with your question.
All right, thank you very much, sir.
Thank you very much.
When we were looking at the different contaminants in water
Yes, sir.
installation, you listed a lot of contaminants. I would like to know if there is no single instrument that can detect those contaminants. And you also mentioned of lime. Lime can be used to stabilize the pH level. Which particular lime were you talking about?
Lime is lime. Now, I'm not talking about orange lime.
Okay.
There is a chemical called lime. I'm not talking about the orange one. There is a chemical called lime that you can use in correcting of your pH. So you can ask your water. Mr. Akolade, please, I will attend to you. I want to see if I can just bring up an example of a water analysis. Okay, I think I got one. Let me just quickly share the slide. How a water analysis look like. Please kindly confirm you can see the slide.
Not yet.
I've already shared it now.
Okay, yes, it's up now.
Okay.
You can see what we have here, physiochemical examination. This first general appearance, color, and odor. This is talking about the physical. You see from here down to this point is chemical, and this is the biological aspect. So that's why I said there are three parameters you check in water: the chemical, the biological, and the physical. You can see this one is having Staphylococcus aureus. Then you can see Salmonella is not there. Shigella is not there. Fibro is not there. Lister is not there. You can see you have iron. Sorry, the network has been so pathetic today. So, okay, Mr. Akolade, go ahead with your question. Mr. Thomas, I'll come back to you. Mr. Akolade, go ahead with your question if you can hear me.
Good evening, sir.
Good evening, Mr. Akolade.
Yes, sir. So I have two questions.
Okay, sir.
Yeah. So for the chlorine,
Yes, sir.
apart from cleaning the germs in the water,
Yes.
what other works does chlorine? What does it do? But
Okay.
because I know chlorine also breaks down the iron inside the water, so I just
Okay.
want to confirm if that is true.
in chemistry, when you add chlorine to iron, it becomes iron chloride. So you are right. It's also break down iron in water. And also, it also serves as a bleaching agent, apart from disinfection.
Yes.
Yeah.
Yes, sir.
So the second question.
So the second question, like there was some expertise were called on to one of the estate around here.
Okay.
So and their observation was that from the aquifer, why the
Okay.
bore was not bringing out enough water.
Yes, sir.
So they said from other estate around that
Okay.
they were using higher pumping machine, like 10 horsepower. So
Okay.
the said estate was using 3 horsepower. So they were
Okay.
not like, so the the estate using 10 horsepower, they
Okay.
were extracting the water from the aquifer. So it's not making the estate with the 3 horsepower to have
Okay.
enough water to
Okay.
to extract.
Okay.
So I was not like, could that be possible? Could that be
Yes,
possible with the quantity of water inside the ground?
it's possible. That means the aquifer, the water that is recharging your borehole and that is recharging the other estate is coming from the same source. So, and because they are using higher capacity of
Okay.
pump, there is tendency that that pump will draw that water and you might not get enough water. So the best you can do is that you can,
Mm.
if you can't get 10 horsepower, you can increase your pump to like maybe around 5 or 7.5 horsepower. It will improve the output of water you are getting, so that you share that water
Okay.
in equal time. It's possible. And that's why it's always very necessary for you to conduct a geophysical survey, because if you are if you are if you are moving to a new environment, for instance, let's assume I'm moving to Mowe now, and I get to Mowe and I ask my neighbor, what is the depth of your borehole? And my neighbor said, what he did is 60 meters. If I do 60 meters, by the time that environment becomes fully developed and everybody is doing 60 meters, it will come to a point that the water that is recharging that aquifer will not be enough for everybody within that community. So some borehole will be suffering the loss. The only set of people that will be having water are people who go further than that 60 meters. That's why your geophysical survey is very, very key. So the best you can do is either you get a bigger pump, or you go lower than what they are doing. And before you go lower, you need to do a survey to know which depth you actually needed to go. That will give you a yield. And the other thing is that when you go lower, the water will be recharging your bowl. They might not be getting water. It's possible. I hope that answer your question, Mr. Kolari.
Yes, sir. Yes, sir.
Okay. Mr. Thomas, go ahead, sir. Mr. Thomas. Mr. David Thomas, please, your hand is up. Kindly go ahead with your question, please. Okay, any other question before we call it a day today?
Can you hear me?
Yeah, I can hear you now.
All right, I've been struggling with my speaker, sorry, with
No
my
problem,
mic.
sir.
All right, I have a two question. My
Okay.
number one question is, in a situation where a sewage plant is running and chlorine is dosed, and the odor that is coming out from that particular area is very offensive, why the chlorine is
Okay.
dosed. So I
Okay.
don't actually know what will be the cause.
Chlorine does not remove odor for you. It only does disinfection, bleaching, and ion exchange. The best you can do is to expose that to aeration, or you create a pipe, like the pipe
Okay,
that you always have at the back of your bedroom. You
okay,
create a stack.
Okay.
At that point where you have the aeration, you create a stack and put a cap on it so that you
Okay.
introduce what we call a blower.
Okay.
So the blower injects air into that sewage, and the
Okay.
air from that sewage go through that stack to the
Okay.
space.
Okay.
That will definitely reduce the odor.
Okay. Okay. And my second question,
Okay,
uh,
sir.
my second question is the water treated from the sewage plant. Is it possible that the water can be clean like the one treated from water treatment plant? Because I have an argument with my manager concerning that I was expecting the water coming out from the sewage plant to be very clean like a drinking water. I was arguing
No,
him that it's not possible.
it cannot be crystal clear. That's why you
Yeah.
see. Let's check from your analysis what you have here. Your T turbidity should be less than 10 NTU. So it
Okay.
doesn't mean you shouldn't have turbidity. You are going to have turbidity. It
Okay.
can't be crystal clear like the water coming from treatment plant. No.
Okay.
Mm.
All right. Thank you.
You're much welcome, sir. Somebody wanted to ask a question before Mr. Gentoo. Okay, Mr. Gentoo, go ahead.
Okay, good evening, sir. Can you hear me?
I can hear you, Mr. Gentoo.
Okay, sir. So my question is, so if we want to install an industrial borehole,
okay,
what should be the distance between the borehole and the sockaway?
To me, you should have at least between your sockaway and your ball, you should have at least 6 meters minimum. And that's why most of the time, 6 meters minimum.
Okay, okay.
And that's why most of the time you put your ball at the front of the building and put your sockaway at the back of the building. Most of the time, it's always
Okay.
better that way. Yeah.
Okay, so thank you, sir.
You're much welcome. Mr. Muiwa.
Thank you, sir. Good evening. Now,
Good evening,
sir. Regarding the water treatment, I have seen people using iron tank because over the time, iron tank will start
we start rusting.
You start rotting inside. So,
Yes.
but I've seen, and despite the process of installing water treatment, everything, but so I see that something that is not really good, but I've seen it, people doing it. So, and again, I've seen the practice of the treatment. There is a tank beside the treatment, the tubes, the what you call it, where the water and everything will be inside. From the borehole, there's a small tank. It's always open, where the water will come in first before entering the treatment.
That is what they call the aeration tank.
The aeration tank. But most times it's always open, and inside is most times is always, if they're not doing it, sometimes they might leave it for 1 month, and by the time it's always open, and you start seeing all this green stuff inside, and they're taking it inside, going the treatment. So is it the best practice, or how do we correct that?
Okay. Now, the very first set of material we're using for filtration and aeration is metal. But research proved that metal will definitely, with combination of air and oxygen, will form iron oxide, which is rust. And that's why it is not advisable for you to use metal anymore for both aeration and filtration. So the best you can use is stainless steel or fiber. That is the best you can use. Even for your aeration tank, the best you can use is either stainless steel or fiber. And there are some mild steel, there are treated mild steel that are less prone to, sorry, I have a power outage, that are less prone to corrosion that you can use. So those can be the best option. Then when you have green algae in your aeration tank, is as a result of, because there is, your aeration tank always have 3 chambers. The first chamber is referred to as the turbulence stage. The turbulence stage is where the chemicals that you dose into your water mixes together. So once you are not dosing at that turbulence stage, if you are pouring chemical into your aeration manually, if you are dosing your aeration at the 3rd chamber, you create room for microbial organism to grow at that turbulence stage. So you can be seeing green algae and all those stuff in that stage. But if you are dosing from that, if you are doing a pre-aeration dosing, there is no how green algae can form at that turbulence site. It's as a result of the fact that you are using manual dosing and you are not dosing at that turbulence part of the aeration tank.
Thanks.
You're much welcome. Mr. Vim, go ahead with your question, sir.
Yes, good evening. Thank you, sir. So I have 2 questions concerning sewage treatment. The first question is, when you were going through your lecture, you mentioned that we first have the accumulator where everything comes into. Then
Exactly.
from there, the aeration tank and the primary, secondary, and tertiary. Now, the first question I want to ask is that, where do you now install the sewage pump?
If you are going to be treating your water, you don't need a sewage pump. From the tertiary tank, your water you connect it directly to the public drain. You don't need a sewage pump. And if the level, let me also chip this in. If the level of the public drainage is lower to the top surface of your tertiary chamber, you connect a pipe to the public drain straight. But if your tertiary chamber is lower than the public drainage, this is when you need a sewage pump. You install your sewage pump inside the tertiary chamber because that is where you have more or less like a clean water. So that is the best place you can store your sewage pump.
Okay, now thank you, sir. The second part of it is, sir, now I've seen a facility where the collection chamber is more or less was built like a soccer way. It's underground, but the aeration tank is up.
Yes, it's possible.
Now a pump is installed into the
underground.
Yes, so that it can transfer whatever is coming from the building to the aeration tank, sir. So now you made mention of separation and all. So how do you now do separation at that point? Maybe to screen out those.
That means the process you're having in place is what we call your sewage treatment plant stroke fat trap. If you look at that treatment plant very well, that is what we refer to as stacking. And you're going to definitely have a sewage pump inside the underground tank. That sewage pump is what is going to pump the sewage into the aeration tank. And from the aeration tank, then the water goes through another process of filtration and all those stuff. So when you are doing filtration, all the unwanted foreign material are being filtered out. That is another means of doing what is called skimming. You filter out all the unwanted material like stick, leaves, and every other thing. And the other way you can do it is for you to construct a screen at the entrance of the receiver so that you ensure that the only thing that gets into the receiver is just liquid content with some minor sediments. That's another form of doing it.
Okay.
I hope that's answer your question, sir.
Yes, sir. Okay, thank you, sir. It does, sir.
ask that question concerning sewage plant is being running, is on, then all the processes like chlorine is being dosed, or yet an offensive odor is coming from that area. He now said that chlorine doesn't stop the odor. So what we need to do is to erect a ventilation pipe and send it on the air, just as normal soccer way they did now. Then the odor will escape, and natural ventilation from air will be entering inside there to get the ventilation.
Okay. Yeah, Mr. V. Please, can you hear me?
Yes, sir.
Okay, I hope that provide answer to your question, sir.
Yes.
Okay.
It does.
So, in the absence of no question, let's call it a day today. Thank you, everybody. We meet again during facility tour. That should be possibly September or early October, but the date of the facility tour will be communicated. I pray I'll be available so that we see each other then. We'll go through the practical class of HVAC, sewage treatment plant, water treatment plant, and all the stuff that you can see in a facility on that day. So thank you very much, all the speakers of today. I so much appreciate every one of us. Enjoy the rest of your week and do have a wonderful week ahead. Thank you, everybody.
Thank you, sir.
Lewis, thank you very much, sir.
Thank you very much, sir.
Thank you, Mr. Festus. Thank you, Mr. Muiwa.
Thank you.
Thank you.
Thank you, sir.
Thank you, everybody.
We appreciate you, sir. Thank you, sir.
I so much appreciate everybody, sir. Mr. Chuka, I got your message. Thank you very much.
My pleasure, sir.
Thank you, sir.